I'm today's lecturer, and today we will talk about Chapter 4, Coastal Processes and Structures, and especially height casting and secondary flow, Ekman spiral, upwelling, rip current, and some loop current and gyres. And first, height casting is a way of testing a mathematical model, and height casting is also known as backtesting. It's like forecasting is estimate the future, and hindcasting is kind of testing the model by nowadays data. It's also known as closely estimated inputs for past events are entered into the model to see how well the output matches the known results. It's different with forecast because forecast is forecasting for future data, estimating future data. And this is secondary flow. Here's video.
では二次流れの実験をしてみます。まずたらいを手で回転させてみます。続けてこう回転を持続させると、この中の水は強制図の流れになっています。つまり容器と一体となって回転しています。お茶っ葉は外側続けています。たらいは止まりましたけど、中の水は惰性でまだ回転を続けています。これをしばらく観察していくと、下に沈んでいるお茶っ葉はだんだん内側の方に集まってくるというのが分かります。これは二次流れという現象によって起こるものです。二次流れとはもともと遠心力で水は回っているわけですけど、そこに近いところは流れの速度が遅くなります。これは粘性の影響によって容器を止めると、その容器と同じように流れが遅くなると。流れの遅い底の部分の水は遠心力が弱まりますので、内側の方に流れていく、そういう流れができます。一方、水面から少し離れた水面の上の方、近いところとか真ん中あたり、これは遠心力の影響で、中心が集まった分だけ外側の方の流れができます。このようにその全体の流れ、主流と言いますけど、それに垂直な流れの成分を二次流れと言います。いかがでしょう。お茶っ葉はこのように真ん中に集まりました。これが二次流れの影響によるものです。
As you can see in this video, as the water flows like this circular motion, then perpendicular water flow is generated. So the tea leaves are, you can see the tea leaves are going to center in this video. So this kind of flow is called secondary flow. And also for time arcs near sink vortex. And Ekman spiral is generated by wind. As wind goes this way, then the water moves like 45 degrees, and keep as water get deeper, then it goes like this part, like spiral. And the net water transport is like moving this direction. So as you can see in this picture, as wind goes here, the surface current moves like 45 degrees, and that water transport is 50 degrees. And this is work in little bit deep toward deep water. So T is about 50 to 100 meter. And because of this Ekman spiral, as the wind blows here, as we said, water moves this way. And as water moves this way, here goes empty. So deeper water will arise. So it is called upwelling. It's the opposite way, it is called downwelling. So as you can see in this picture, this is California in USA. Upwelling is generated. So as you know, deeper water has lower temperature. So here is lower temperature here. So upwelling is generated here. And another examples are here. So wind goes here, and as wind goes here, water moves this direction. So here goes empty. So upwelling is generated. And also in this figure, water flows here, and here's some obstacle. So water moves upward. So this is also upwelling. And also in this picture, water moves here. So here gets empty. So upwelling is also generated here. And Langmuir circulation, it is about wind moves here, then some turbulent flows are generated. The difference about Ekman spiral is it is more shallow. It's only 6 meters. And as wind moves here, then water gets like this. Water moves like this direction. And another one is rip current. Rip current is generated by when wave comes, then water goes opposite direction of wave comes. And here's also video.
You might have heard them referred to as undertow or riptides, but these ocean phenomena are actually rip currents. Rip currents are narrow currents in the surf zone that move quickly away from shore. A typical rip current ranges from 50 to 100 feet wide and can extend 100 yards or more offshore. It can reach speeds of over 5 miles per hour. That's faster than an Olympic swimmer. That makes them dangerous and potentially deadly, and scientists want to learn more about them so we can better forecast when and where they will form and keep beachgoers safe. Here's what we know. Waves don't have to be huge for a rip current to form. 2 or 3 feet are all it takes. And the weather doesn't have to be bad for a rip current to emerge. They often occur in the nice days after a storm. They're usually strongest near low tide, but can form at any time. Rip currents often form where sandbars are near the shore. They occur at breaks or channels in the bar. They're often difficult to see, but you can spot them in areas where waves aren't breaking, or where there's foam, seaweed, or discolored water being pulled offshore. It's easier to see a rip current from higher up, such as from the beach access over dunes or a lifeguard's tower. Rip currents are a hazard for beachgoers, but by knowing the dangers and what to look for, you can avoid being caught in the grip of the rip.
This video is about rip current, and as the video mentioned, rip current are like this picture, and rip current are wave energy escaping through shoreline. So stream of water returning out to sea through the surf zone and flows up to few hundred meters offshore, then it dissipates. And along shore currents is like not perpendicular waves, parallel waves like coming like this way. And sea breeze, it's day, wind goes like this way, and at the night it goes like this way. Because at the night land is cold, and so wind blows this way, and at the day land gets hotter faster, so wind goes this way. And here's another video. This video is about seawater moving. And another video is here. This video is also about seawater moving. As you can see in these two pictures, there was some circular movement in seawater. So as you can see in this picture, this kind of circular motion is called eddy, mesoscale eddy formation. So when the warm water and cold water meet, then the water moves like this way, and then the time goes, this kind of circular motion is generated, and we call this, all of these are eddy. So like this picture, and also here's another example of eddy. And because of it, there is you may heard about ocean garbage. So there is 5 big ocean garbage which is generated by the eddy. So we call those 5 gyres.
So a gyre is a natural phenomenon. A gyre is simply a rotating current system that's comprised of the Earth's rotation coupled with currents and prevailing winds. So it's essentially like a massive whirlpool, a vortex in the oceans. Say a piece of floating plastic from California in the North Pacific Gyre can take 10 years to make the rotation from California to Japan and all the way back.
So what we have found is that these plastic particles are not just in the North Pacific Gyre, they're in all 5 subtropical gyres, and all these gyres have several garbage patches in them, 8 garbage patches total in the 5 gyres.
So that was our inspiration to start the 5 Gyres Institute, to look at this plastic pollution issue on a global scale and try and show the world this is an international problem. These plastics are coming from every continent in the world, and solutions have to be on the international level. When I first heard this talk in 2001 from Captain Moore, I heard description of an island of garbage that people were calling the Great Pacific Garbage Patch. In the media, it was described as a Texas-sized island.
It's really hard to quantify how much plastic is floating in the world's oceans. These garbage patches that exist in the gyres, they're elusive, they change shape, they move around. You may trawl for 10 hours straight, you'll get a handful of plastic. You put it back in 10 hours more, and there's nothing.
So it's essentially like a plastic soup of all of this disposable waste that we create on land masses from California to Asia, Canada, Mexico, enters this North Pacific gyre and gets swept up into this accumulation zone.
Islands in the gyres we're discovering are the natural nets for trash at sea. It's impractical to try and scoop out trash out of the ocean. What we can do is wait for it to wash ashore. So to clean a gyre, clean your beach, clean your watershed, clean your street. As close as you can get to the source is a better way we can solve the problem of plastics in the ocean.
Okay, and this is all what I prepared. Thank you for listening.
Thank you. Any question to Yu-san? No? Clear. All right, then we can move on to a discussion session first, led by Ki-hyun.
Okay. Oh, not this one, sorry. 옛날 거잖아. Can you see the PPT slide?
Yes, but in smaller size. Okay, good.
Okay. So for my second discussion, I'm going to talking about the nuclear ships because I am in the nuclear and quantum engineering department. So my topic is about the using a nuclear ships as a merchant ship or commercial ships. So for historical view, there is only 4 of them. So were used for a civilian merchant ship, U.S. and a Savannah of the United States, or Tohan of Germany, thermal ports of the Soviet Union, and Muchu for Japan. And the Muchu was retired without the operation due to the technical problem. And the NS Savannah and Otohan operate without the technical problems, but they are retired for the economical problems. They cannot afford the nuclear fuel cost, and the diesel cost is much cheaper than the nuclear fuels. And the last one, the thermal ports, is the commercial ship with the ice-breaking function. So it is still used for the arctic route that's going to the northern sea of the Russia. And there's another example where the nuclear ships are used in the civilian case is the icebreakers. In Russia, nuclear icebreakers are operated to break the ice on the northern sea route, and they are now build a new nuclear icebreaker in these days. Because the advantage of the nuclear icebreaker over the diesel icebreaker is that they are more powerful and have a long fuel exchange cycle in the cycle. The longer fuel exchange cycle is important in the Arctic because in the Arctic, the supply is difficult, so the longer fuel exchange cycle is very important for the Russians. So the first discussion topic is that will the nuclear ships be used as the merchant ships in the future?
Yes, I think in the end, I think the nuclear merchant ship would be commercialized in the future, but I think it is takes some take long time. The key factor to develop reinforcing the hull is the protect the nuclear reactor from the external force. For example, wind force, wave force, and current force. Since the environment force of offshore nuclear power plant caused the severe damage, so it is needed to the strict rule and reinforced plan different from those of existing commercial vessels.
Oh, okay.
Yeah, I think regarding the use of nuclear ships for merchant ships, the fact, like someone mentioned, like there's the fact about having a reinforced hull, but we also have to note that there are a lot of merchant ships, so accidents are inevitable, and the nuclear technology should be developed to the point where an accident would not cause some kind of environmental disaster. So I'm not sure what's the current technological situation is for nuclear power plants. Like if an accident occurs, how big of an environmental disaster it will be. But if that can be solved, if the problem of environmental disaster due to an accident could be solved, I think it is inevitable that nuclear ships will be used in the future.
Oh, okay. Can you hear me? Oh, so as I think we have discussed before, nuclear energy, using nuclear power as nuclear power propulsion for ships is like environmentally it's very efficient and it's undisputed. But I think, as Sungmin will say, it's futuristic, but I think we will be using in the future, but which future we are talking about, that depends. Maybe we'll be using after like really long time in the future, not the near future, but the far future. I think the first thing for that is maybe one thing is the public perception, because nuclear powers are commonly associated with disasters. So we have like the bombing of Hiroshima and Nagasaki in World War II. There is Chernobyl and Fukushima. So I don't think people would be willing to use a ship that's powered by nuclear propulsion. And also technically, if we see it, I think in ship, so we are going, the solution now is nuclear reactor, right? So being so close to the nuclear reactor, it may expose the passengers and also the operators of the ship to dangers. So I think the longer, especially those who are staying, the operators, they'll be exposed to the nuclear radioactive substance for a long time. That means they are going to be highly exposed to it, and maybe it will cause some kind of problem. And also operating nuclear reactor in water will be a bit difficult. So nuclear reactor so far has been, those used are on Earth, right? So, but operating them in a ship that's moving in the water would be another challenge. So there should be a new way to handle that too.
I think I don't know if it will definitely be replaced by nuclear ship, because I think nuclear is over spec for warship, not warship, merchant ship, because nuclear ship is usually used as warship, and warship is floating for a long time, and nuclear is a good solution for long functioning. But merchant ship, I think it doesn't need to such a long day. So I'm not agree with nuclear ship will be used as merchant ships.
I agree with Yusang's opinion. The main factor is the productive cost. In addition to others' opinion, it is considered necessary to establish a treatment standard for retiring a nuclear ship due to the risk of radioactive leakage.
Okay, thank you for the opinion. And the one of the reason that the nuclear ship was failed to success in past aboard the Ottohan, some ports say they didn't want they didn't give the permission to Ottohan to come into their ports because of they cannot think that the nuclear ship is not safe. So the another problem is that we need the regulation for it. What are the necessary regulations if the nuclear ships are used for commercial ships?
So we already have like some regulations, right, for nuclear propulsion. So I think there is some part of the International Convention for the Safety of Life at Sea. It's an IMO regulation from 1974. It provides a basic requirement for nuclear powered ships. Yeah, so that deal with the sea at life in large, like hazard regulations. That would be one of like regulations like that would be one of the regulations that are required.
And I think some regulations related to carrying load, carrying carriages can be generated. I'm not sure.
Unlike nuclear submarines, nuclear merchant ships undertake the violent 6 degree of motion and acceleration by wave wind current. So it could give impact pressure to ship shell. So it is necessary to the very strict design rule to sufficient safety factor against the external force. In particular, most of LNG ship bulkhead of fuel tank currently use double bottom, and so it seems that reinforce through triple or quadruple reinforce is necessary.
I think an increase in nuclear ships can also raise the issue of safety. So if a country has any malicious or evil intent, they could maybe use a nuclear merchant ship as a Trojan horse. So I think from that standpoint, nations would be very wary about allowing nuclear ships in their port, as you have already mentioned previously. So I think I'm not sure what necessary regulations should be placed, but I guess standardization process and a regular check by an independent authority, like regularly checking the ship structure, could be useful to make sure that no such malicious activity can be done using nuclear merchant ships.
Also, maybe if I can add about the safety of the people on board in the ship, maybe the passengers or the operators. So from the nuclear reactor, the thing that affects them is how much they are exposed to the radiation from the radioactive material. So maybe some regulation about the amount of time the ship can stay on sea may also be needed to reduce the exposure time to the people. So there should be like limited exposure, right? There is like the safe amount of exposure. So to put the exposure in that limit, maybe the time limitation should be provided.
Okay, thank you for your ideas. This is the all of my discussion topic, and thank you for participation.
Okay, good discussion. Good topic. Nuclear ship, commercial ship. Right. Yeah, one thing I have in mind is that there is an acceleration from outside, but also there is a internal acceleration due to motion of the ship. So external shock can be coming from, say, collision somehow, but also the ship motion, because the nuclear physicists, they want to know what can be the acceleration to the nuclear reactor, because they may have a limitation on possible acceleration to the reactors. So they asked me what can be the maximum acceleration inside the ship. That can be another topic. All right, so then we have enough time to go to my lecture, second lecture. Okay, let me share my screen. So